Hello, I'm Onjigo from OnjigoPro.llc, and this is part 3 to the Make Me Onjibot series. I figured I'd start off by showing you guys everything I have to get this to work. Here I have a 3 to 12 volt DC motor. Attached to it is a blade. Here is a speed controller. Here's my 3 volt battery with a battery case. This is the Raspberry Pi 3 with a power cord, HDMI, USB cords for the mouse and the keyboard attached to what is my monitor here at the top. Once again, this video is not to show you the fundamentals and basics of setting up Raspberry Pi. I'm not an expert, but I'm going to just show you the basics of what I've got working. Here I have the GPIO pins, the cords coming from Raspberry Pi to the speed controller, because that was my only way of getting the motor to work without using a breadboard. So I just started testing things and I managed to get it to work without looking at any other outside sources. I just started playing with things until I assumed, hey, it didn't blow up. What you see is the 3 volt batteries is for testing purposes, and there's actually no need for it in this tutorial or in this video. The 3 to 12 volt motor is actually connected to the speed controller. The speed controller switch is turned all the way off. The GPIO pins from the Raspberry Pi are occupying the same space as the 3 to 12 volt motor. The Raspberry Pi is on, so what I gathered is that it is conducting energy or electricity to the 3 to 12 volt motor, even though the switch is turned all the way off on the speed controller. So when I turn the speed controller on, it doesn't matter if the battery is on or not, or hooked up or not, because the power is coming from the Raspberry Pi. For me, it's good to use a 3 to 12 volt generator motor because it's not set at a set voltage. So it can toggle between 3 to 12 volt and definitely 3 to 5 volt, and I'm only using 5 volts with the Raspberry Pi. You guys can correct me if I'm wrong, but I'm just happy that it's working. Here on my Raspberry Pi 3 desktop, we have the Python editor and an HTML interface. This is the user interface that I created to write text directly into the conversation text file in my hosting. Without loading a PHP, it writes directly into the text file. The only reason I used UE4 was to store information in UE4 outside of HTML. I was familiar with blueprints, so that's what I used. So let's get started. As you can see, the motor is off, so I'm going to type motors on. So now we have motors on. Now you can see that the motor was on, and I'm going to type motors off again. So there we go, motors off. And the motor easily turned off. Now the only downside is communication with online and the speed. I believe if you have fast internet, then the communication should go by fast, meaning it should turn off on fast. If you're flying a drone, then there's definitely going to be a delay, and it's going to be based off of your internet connection. This is definitely because it's online, but eventually I'll show you how to do everything offline. So now you're going to watch a speed video of me typing fast with Python. This will show you how to communicate with the text file in your online hosting, and that text file is the conversation text file, or whatever you want to call it, in which Raspberry Pi will be reading constantly, or UE4 will be writing into on command. I've embedded some notes inside the script to help you understand what I'm typing. By the end of this video, you should be able to turn your motor on and off. So if this video is helpful to you, please like and subscribe. For video 4, I will show you the code for the online HTML interface. I will also show you the Python code for controlling the motor offline. I don't have an offline user interface yet,